Welcome to The Explainer. Listen, today we are stepping into an elite masterclass designed specifically for you, the Cambridge Assessment International Education candidate. I am your master coach, and whether you are sitting for AS level or pushing hard for that top-tier A-star and A-level mathematics, you are in exactly the right place. Today, we are taking a highly academic, strictly strategic approach to Syllabus 9709, focusing entirely on Section 2.5 integration. Now, let's get one thing straight right out of the gate. This is not some basic review session where we just memorize a few formulas and hope for the best. No, we are going to decode exactly how Cambridge examiners grade your papers. We're going to break down how performance scales on the actual examiner's grid, moving from the lowest foundational bands all the way to a flawless, clean mark yield. We're going to dissect complex questions, map out clear structural frameworks, and manage those intense time metrics under extreme exam pressure. All right, let's dive into this and fundamentally change how you conquer your exam.
Okay, take a look at this. What's truly striking here, what you really need to absorb, is the sheer, massive weight of the syllabus section we are dealing with. Mastering 2.5 integration commands, approximately 15% of your total exam marks. Think about that for a second. 15%. That is an extreme high-stakes zone. We're talking specifically about integrating e to the power of ax plus b, 1 over ax plus b, the sine of ax plus b, the cosine of ax plus b, and the secant squared of ax plus b. A lack of precision here doesn't just cost you a point or two, it literally alters your final grade band. It's the difference between an A and a B, or an A and an A star. You absolutely cannot afford to be superficial with these 5 specific functional forms. The examiner's grid is heavily weighted toward your ability to manipulate these exact expressions. When your eyes scan the paper and see e to the power of ax plus b, your brain needs to instantly trigger the standardized processing sequence that Cambridge demands. We are going to deconstruct exactly how to secure every single fraction of that 15% mark allocation.
And this brings us to our core operational strategy for this explainer. We are looking directly through the lens of a senior examiner. If you look at the global principal examiner reports, they consistently point us toward a critical concept, the method mark strategy. In Cambridge mathematics, it is a fatal flaw, a literal trap, to believe that only the final boxed answer at the bottom of the page matters. Examiners actually award marks for the process. They are actively hunting for your methodological footprint on the page. For instance, when you integrate the sine of ax plus b, the method mark is awarded for demonstrating conceptual mastery of the reverse chain rule. They want to see you explicitly showing that division by a, and proving you remember the negative sign for the cosine conversion. If you just jump straight from the question prompt to the final answer in your head and write nothing else down, you are actively forfeiting those crucial method marks. The marking rubric scales based on your evidence-based reasoning and your clear working. We are going to use this insider advantage today to completely optimize your mark yield.
So, here is our roadmap for the session. We've got 4 critical phases. First, the core integration principles. Second, the method mark strategy. Third, a universal problem-solving framework. And finally, the top examiner warnings. Let's move.
Section 1, Core Integration Principles. This is where we lay down the absolute theoretical architecture of Section 2.5. Right, so the absolutely crucial point here is what Cambridge actually defines as mastery. The assessment framework targets distinct cognitive domains: knowledge, application, and analysis. It is simply not enough to just memorize a textbook formula. Top-performing candidates exhibit what examiners call connected understanding. This means demonstrating conceptual mastery that is explicitly transferable to unfamiliar exam contexts. Let's break that down. You might perfectly understand how to integrate 1 over ax plus b to get the natural log of the absolute value of ax plus b, all divided by a. Okay, great. That is assessment objective 1, basic knowledge. But what happens when that exact expression is buried inside a complex kinematic problem involving velocity and displacement, or an area calculation bound by a multiple axis? That requires application and analytical depth. You have to understand the causal relationships. Also, we need to decode the command words. If a Cambridge question uses the command word analyze, but your response only states the formula, you have immediately capped your score at the lowest band. It doesn't matter if your math is technically flawless. Misinterpreting the command word triggers an immediate marking penalty on the examiner's grid. Let me paint a picture for you of how this actually plays out under intense exam conditions. Just yesterday, I was running a mock session with 2 of my top scholars. Let's call them Alex and Sam. We were deconstructing a massive high-tariff past paper question involving the integration of secant squared of ax plus b to find a volume of revolution. Alex, bless him, is an AO1 machine. He overloads his responses with raw factual definitions. He looks at the question and says, Coach, I'm just going to state the integral of secant squared as 1 over a times the tangent of ax plus b, plug in the limits, boom, we're done. That right there, that is superficial breadth. But then Sam jumps in. Sam is a fast writer who constructs highly persuasive arguments, but sometimes misses explicit restrictions. Sam says, no, Alex, the command word is evaluate the appropriateness of the model. We can't just calculate it, we have to write an analytical thesis. And they just started debating the structure right there. And Sam was on the right track, but I had to step in. I told them, an analytical candidate explicitly states the theoretical foundation. You write that by applying the integration principle of secant squared. We derive the volume, yes, but we absolutely must evaluate the domain restrictions of the tangent function between these specific limits to ensure the model actually remains continuous. That analytical link, that thesis, is exactly what unlocks the highest marking bands.
Section 2. The method mark strategy. This is where we take all that theoretical debate and translate it into a strict technical methodology. Now, I need you to pay incredibly close attention to this standardized processing sequence. The examiner reports are explicit that the presentation of information and integration follows strict conventions. If you want those method marks under pressure, you must move sequentially through this 5-step sequence. Step 1. Identify key elements. Which of the 5 core functions is sitting in front of you? Step 2. Apply relevant principles. State the correct integration rule explicitly before you execute it. Step 3. Execute analysis with clear working. This is the absolute heart of the method mark. You must explicitly write out your compensation factors on the page, like multiplying by 1 over a. Step 4. Verify results. Check for reasonableness. Did you remember the constant of integration, plus c for an indefinite integral? And step 5. Present in appropriate format. Proper headings, proper terminology. For example, if you are integrating 1 over ax plus b, your final format must use the natural logarithm, denoted as ln, with the proper absolute value bars if the domain requires it. You cannot afford to lose marks on sloppy presentation.
Okay, time out, strategy check. Before we unlock this next top-band paragraph structure to help you crush your upcoming sessions, let's make sure your revision feed is perfectly optimized. Take a second right now, literally right now, to subscribe to Ace the Exams at the handle @AceTheExams. Enable all notifications, hit that bell icon so you never miss our weekly Cambridge exam breakdowns. It doesn't matter if you are sitting for IGCSE, O-Levels, AS, or A-Levels, we're dropping masterclasses that will dramatically upgrade your system. All right, system upgrade complete. Let's get back to the operational matrix.
Section 3. The problem-solving framework. We are shifting from pure mechanics to the overarching architecture of a top-tier response.
I want you to pause and practice with me for a second. Ask yourself this. Why do exceptionally smart students find interpreting complex texts and data so incredibly hard during the actual exam? Think about it. You're sitting in the exam hall. The clock is ticking down. You are presented with a massive half-page paragraph detailing a population growth model that eventually requires integrating e to the power of negative 0.5x. The pure math is honestly straightforward, but extracting the correct data inputs and interpreting the relationships under that extreme pressure causes massive cognitive overload. The final score drops not because the candidate can't integrate an exponential function, but because they cannot navigate the data matrix. They fail to draw evidence-based conclusions from the text. To combat this, top candidates use a relentless, universal protocol.
And here is that exact deconstruct, solve, evaluate protocol. Let's go back to my scholars, Alex and Sam. They were working on a problem integrating the cosine of 3x plus pi over 4 to find displacement from a given velocity equation. They hit a massive structural roadblock mid-paragraph. Their math was sound, but their final evaluative text completely failed to link back to the main thesis of justifying the maximum displacement. I stepped in and deployed this exact matrix. I had them rewrite the text out loud, line by line. First, identify given information. Alex said, okay, velocity follows a cosine function requiring integration. Good. Next, break into logical steps and solve systematically. Sam writes, integrating this yields 1/3 sine of 3x plus pi over 4 plus c. Perfect. Then check for reasonableness. I told him to mentally differentiate it backward to ensure it returns to the original velocity. It did. Finally, make justified recommendations. Rather than just dropping a raw number on the page, they engineered a flawless response block. By evaluating the definite integral between the specified boundaries, we justify that the maximum displacement occurs exactly at time t equals 2.5. They deconstructed the text, solved the math, and evaluated with hard evidence. That is the gold standard.
And look at how beautifully this extends into higher-level comparative analysis. The examiner reports clearly state that comparative analysis requires identifying similarities and differences. Now, you might be thinking, Coach, how does comparative analysis apply to pure math? It means using comparative connectives and anchoring your mathematical arguments with hard evidence. Let's do a 60-second visual data scan challenge right now.
Imagine a complex source chart on your paper, asking you to compare the area obtained by integrating a curve directly versus using a geometric trapezoidal approximation. You cannot just list two disconnected numbers. You must construct an evaluation response. A top-tier paragraph reads like this. While both methods provide an estimate of the area, integrating 1 over 2x plus 5 directly yields an exact logarithmic value, whereas the geometric method significantly overestimates the area due to the curve's explicit concavity. Do you see what we did there? We anchored the argument. We used comparative connectives like whereas, and we provided evidence, the concavity of the curve. That is the Peel framework, point, evidence, evaluation, link, applied flawlessly to Cambridge mathematics.
Section 4. Top Examiner Warnings. We are now shifting directly to the Principal Examiner reports to run a compliance audit and reveal the traps. All right, it's time for our second interactive challenge, Spot the Examiner Trap. I'm going to detail the top 3 structural roadblocks where students consistently bleed marks, straight from the global reports. Rank 1, wrong approach for context. This is a brutal trap. You see an expression that looks like a fraction, say 1 over the quantity ax plus b squared. A stressed student immediately tries to use the natural log integration rule because this saw a fraction. Trap triggered. Because the denominator is squared, it's a power rule situation, not a logarithmic one. Using the wrong approach triggers an immediate, heavy marking penalty. Rank 2, forgetting format and presentation. We talked about this, missing the plus C, forgetting absolute value brackets. This poor presentation breaks the procedural framework. Rank 3, answers not specific to context. Imagine a medium-tier student paragraph. The math problem is set in a real-world engineering context, calculating the volume of a manufactured part using sine of ax plus b. The student calculates 14.5 and stops. The examiner trap is sprung. You must specify the units. You must explicitly relate that numerical answer back to the physical context of the manufactured part in a concluding sentence. And here is your final, high-impact compliance audit step. Look at this quote. Examiner alert. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. If a multi-part question asks you to integrate and then evaluate a stationary value, do not just blindly start differentiating and integrating. You must explicitly state, mathematically, what a stationary value actually is before you process the numbers. Write down that the derivative equals 0. A lack of structural precision regarding definitions will drop your mark band instantly. You have to prove to the examiner beyond a shadow of a doubt that you possess connected conceptual understanding, not that you're just a biological calculator. Okay, let's distill this entire masterclass into 3 universal Cambridge operational rules that Alex, Sam, and now you possess. Rule 1, the 3-step question scan. You must decode the exact command words, analyze, evaluate, state, before your pen ever touches the paper. Rule 2, the marks per minute formula. Allocate your timing strictly based on the mark tariff of that specific integration problem. And Rule 3, the post-writing compliance audit. Run your final paragraph through a mental checklist to ensure your format, context, and terminology perfectly align with the examiner's rubric. If you execute these rules across our 5 core integration forms, you will absolutely dominate that 15% mark allocation. Now here is my intense final call to action for you. If this structural breakdown gave you that aha moment, I need you to subscribe to Ace the Exams at Ace the Exams right now. Click that notification bell so you are locked in for our weekly grade masterclasses. And I want you to drop a comment below right now. Tell me exactly which Cambridge subject and which level, IGCSE, O-Level, AS, or A-Level, you are preparing to conquer next. Stay strategic, trust the framework, and I will see you in the next explainer.